4.5b, integration, use substitution. We are going to change variables today, but we're going to have definite integrals now. So let's do this first one. So now we have an integral from 0 to 4 of square root 2x plus 1 dx. So the chain rule happens here. Sometimes it doesn't, but right now I have a 2x plus 1. So that is going to be a u substitution. So I'm going to change that to be u equals what?
2x plus 1.
2x plus 1. All right, so what would be my du? 2 dx. All right. So right now, I don't want to put the integral from 0 to 4 because now I have it in terms of what? U. Now, what do I bring out front? A 1/2. All right, so just like yesterday, I still have those rules to apply. So now, what is my antiderivative? U to the what? Okay, 2/3 u to the 3/2. But the 2/3 plays with the 1/2 to become what?
2/6 is 1/3.
1/3. All right, so now I have 1/3 u to the 3/2. But I don't want to mess with it like that because I need to be in terms of what? X. I need to be in terms of x. So now I have 1/3, and then I have 2x plus 1 to the 3/2 from 0 to 4. You following me? So now let's do some math here. So now I substitute in 4. So the first fundamental theorem of calculus. So now I have 2 times 4, which is 8. 8 plus 1 is 9. So 9 to the 3/2 power. This is where I'd square root first, and then I'd cube it. So I square root it, and so I get 3. 3 cubed is 27. So now I have this 1/3 chilling still, because I don't want to deal with big numbers. So now I have minus. Now I substitute in 1. So 2 times 0 is... not 1. I substitute in 0. So 2 times 0 is 0 plus 1. 1. 1 to the 3/2 power is 1. And so I end up with 26 over 3. So the area under the curve from 0 to 4 of square root 2x plus 1 is 26/3. Now, I want to show you another way to tampa, and I honestly think it's easier. Another method which is preferred is changing the limits of integration when you change the variables. And I want to show you how this works. So when we take an antiderivative in terms of u, honestly, I like to keep it there. But to keep it there, you have to change the limits. All right? Because I can't put 0 to 4 because that's in terms of what? U. So I want to kind of go from here. So we'd have this 1/3 u to the 3/2, right? We did that perfectly by our u substitution. But I want it in terms of u. So u is equal to this 2x plus 1, right? And so now let's change our limits. Well, this is in terms of x for 0 to 4. So now let's substitute in 0 in right here. So if I substitute in 0 right here, I end up with my new lower limit is what? 1. And then my new upper limit, and when I substitute in 4 right there, my new upper limit would be what? 9. And so now I would end up with 1/3 times, now I can just go straight there. So 9 to the 3/2 power is, guess what again? 27. 1 to the 3/2 power is 1. So guess what we're left with? 26 over 3. A lot of the times it saves some time. Okay? Now, should you still get the same answers? Yes. However, here is my warning for you. This is what I see sometimes. Sometimes people change their limits and then put it back in terms of x. Don't do that. If you change your limits, you need to keep it in terms of u. If you put your x back in, you have to keep your limits in terms of x. Are you following me? So don't change both, okay? So anyway, that would be my warning to you. All right, so let's do some. So now I have the integral from 0 to 1 of x times x squared plus 1 cubed. All right, if I were doing this old school method, I would have to expand this cubic, but I don't want to. I want to go real quick. All right. So what is my innermost composite? X squared plus 1. So now my u is equal to x squared plus 1. So what would be my du? 2x dx. Did it cover?
No. Well, the x.
Yes, it sure did cover my x and my dx, but did it cover perfectly? No. So what gets brought out front? A 1/2. Now, I personally love to change my limits. It honestly saves time. So if I have u cubed du, I want to change my limits right now. I'm telling you, it's easier. All right, so let's change my limits. So if I substitute in my lower limit, if I substitute in 0, because that's my lower limit right now in terms of x, if I substitute in 0, what do I get? 1. So now my new lower limit in terms of u is 1. And what's my new upper limit going to be? 2. All right, I substitute in 1 in for x, and now I'm in terms of u. So do I ever have to go back to x? Never go back to your x. All right. All right. So then what is my antiderivative? U to the 4th over 4. So 1/4 plays with 1/2 to be 1/8. So now I have 1/8 u to the 4th from 1 to 2. All right. So now I just substitute in 2. So now I have 1/8 times 2 to the 4th. That was part of your quiz that you'll get back soon. 2 to the 4th is what? 16. Very good. Minus, now I have 1 to the 4th, which is 1. So I end up with 15/8. All right. Pretty good? All right. All right, so now I have the integral from 1 to 5 of x dx over square root 2x minus 1. Now, this is very similar to Katie's problem. All right. Because what's going to be my u? My u is 2x minus 1. So what would be my du? 2 dx. So right now I have an integral of square root u over, or under, I'd still have x du going on. But what needs to be brought out front right away?
1/2.
A 1/2 needs to be brought out front. So what's wrong with this thing again?
We have an x that's
We have an x that's not going away. So what do we need to do? We need to solve for x. So now I'd have u what? X is equal to u plus 1 over 2. All right. So now I'm going to take this and I'm going to substitute it in right there. All right. I want to bring out the 1/2 thing. You see how it's over 2? So 1/2 is going to mess with 1/2 to become what? 1/4. And then I'm going to say it's u plus 1. And then it's really over square root u, but then this is really u to the what? Negative 1/2 du. Now, this is where I'd like to change my limits right here. All right. So my lower limit right now is what? 1. That's in terms of x. So now I'm going to substitute in 1 right here. So 2 times 1 minus 1 is 1. So my lower limit is still 1 in terms of u. Well, what's my new upper limit? My new upper limit is 9. All right. And so now let's do a little bit of math. We need to distribute this x or u to the negative 1/2. So I have 1/4 the integral u to the what? U to the 1/2, and then plus u to the negative 1/2 du. All right, so let's antiderive. So what is the antiderivative u to the 1/2? We've done this a lot. 2/3 u to the 3/2. And then what is my antiderivative u to the negative 1/2? 2u to the 1/2 from 1 to 9. All right, so now let's use some first fundamental. So now I have 1/2 chilling out front. So then 9 to the 3/2 power is what? 27. So 27 messes with 2/3 to become what? 18.
How do we get 1/2?
Yes,
Yeah, that's what I was gonna.
1/4. Thanks. This is 1/4. All right. Thank you. I appreciate it. All right. All right. So then I get 18, and now I substitute in 9. So 9 to the 1/2 power is 3. 3 times 2 is 6. All right. And then minus. Now I'm going to substitute in 1. So then 1 to the 3/2 power is 1. So then I end up with 2/3, and then plus 2. And then we just need to do a little bit of math. I'd like to work with my whole numbers first. So 18 plus 6 plus 2 is 20.
18 plus 6.
Oh, ooh, what did I not do?
Distribute.
Distribute the negative. Pew, pew, pew. All right. So I did kill a kitten, didn't I? All right. So what do we end up getting there? 22. So now I have 22 minus 2/3, and then it's still times 1/4. Well, what is 22? What should I think of that one as?
66 thirds.
All right, so I should think of it as 66 thirds. So then I end up with 64 thirds. All right. What else could I do with this? So 64 is also divisible by 4, so I end up with 16 thirds. So the area under my curve from 1 to 5 of that initial one is going to be 16 thirds. That is technically what it will look like. All right. However, when I do it in terms of u, now it looks like this. But I would then still have the same area under my curve. All right. All right, let's keep moving. Here we go. So now we got some trig going on. All right, and you had a problem similar to this yesterday on your homework. So I have the integral from 0 to pi over 4 of tangent cubed theta secant squared theta d theta. So I had somebody ask me about this earlier. Which one's going to be your u? You really only have a couple choices. What are your two choices you can kind of use as a u? Tangent or secant. All right, I'm going to choose the wrong one first. What if I choose secant to be my u? If I choose secant, let's just go over why this doesn't work. If I choose secant, what would be my du? Secant tangent. All right. Now, it could cover that. All right. But did it cover this one? No, because what's left over there? I have a tangent squared left over. All right. And so that didn't cover right. So that's not the way we want to go to Tampa. All right. That doesn't mean you messed up completely and you're done. Let's try a different way. So now let's pick my correct u. What is my correct u here? Tangent theta. So what would be my du? Secant squared theta, d theta. Do you see how that one covered? Like freaking perfectly. All right. So now I have an integral of u to the third du. That part is my du. I personally want to change my limits right here. So my old limit is 0 to pi over 4. If I substitute in 0 in terms of theta, so what is tangent of 0? It's not a trick question. 0. All right. And so I end up with 0, 2. Now I substitute in what? Pi over 4. I'm substituting pi over 4 here. So what's tangent of pi over 4? 1.
Excuse me, Mr. Flick.
So now let's take an antiderivative. So what's my antiderivative? U to the 4th over 4 from 0 to 1. So now when I substitute in 1, I end up with 1/4 minus 0. So I still call that 1/4. All right. Pretty easy. Do you see how changing variables with u substitution is so much easier than just going back in terms of x? All right. There you go. Let's get some practice.